Hello there. Welcome back. I guess we're going to cover a little bit more. We're still on the subject of aircraft fuel systems, and we're going to look at the requirement for fuel jettisoning. All right, looks like we're all set. Here's an example of the requirement under section 41, which is uh, basically the same system that the the regulation up for the 147 schools that we operate under. There's an appendix that includes all the things that you need to learn, and one of them is number 41, check and service fuel dump systems. Now, it's only a level one requirement, so you're not going to actually go out to the aircraft and manipulate the various dump systems, but you do have to have a good understanding. Here's what the school is um, recommending. The reasons for requiring fuel dump systems, and after this presentation, you'll know those reasons. Two, the methods used to control the operation of the fuel dump chutes and valves. You'll have a general understanding there also. Three, the principal safety requirements for a fuel dump system. And four, the purpose of jettison pumps in a fuel dump system. Basically, that's the four areas we're going to cover. First of all, look at the part 23 requirement. Now, it's been part 23 all along for us. So um, this one here, it looks like it's going to start out a whole section of FAR 23 because it starts with 1001. So the first requirement, probably under the fuel subsection, is the fuel jettisoning system. And the actual requirement is if the design landing weight is less than the allowable takeoff weight, the airplane must have a fuel jettisoning system installed that is able to jettison enough fuel to bring the maximum landing weight down to the design landing weight. Uh, Basically, if the jet's taken off and it's got extra fuel, say it weighs 30,000 pounds, but the the landing weight, you don't want to land with 30,000 pounds. They're anticipating that you're going to burn a lot of fuel, and the design landing weight might only be 28,000. But if you do have to turn around and land, you are going to have to jettison the fuel, and they do that right off the coast here over the ocean. A definition, it's a fuel jettison system is a system installed in most large aircraft that allows the flight crew to jettison or dump fuel to lower the gross weight of the aircraft to its allowable landing weight. So that right there you see the reason for having a fuel dump system. That's the primary reason. Otherwise, I can't think of too many other reasons why you would want to dump your fuel. Boost pumps in the fuel tanks move the fuel from the tank into a fuel manifold. From the fuel manifold, it flows away from the aircraft through dump chutes in each of the wing tips. The fuel jettison system must be so designed and constructed that it is free from fire hazards. Free of fire hazards. They also do not want any of the fumes to enter any part of the aircraft. You're dumping it. You certainly don't want it in the passenger compartment, all the fumes, and certainly no fuel itself. The fuel must discharge clear of any part of the aircraft, and the jettisoning operation must not adversely affect the controllability of the airplane. And I think this is an illustration of it doesn't look like it's in the fuel tip, in the wing tip though, does it? So this may or may not be a jettison in action right there. It probably is, but if the nozzles or the dump valve, what was it called? What was that called? Dump chute is located in the wingtip, and you're going to want to lower some of the weight in this wing, and the fuel tanks are usually more towards the center of the aircraft. The boost pumps are going to actually pump it out so it'll go out the end because it's not going to naturally flow that way. The fuel jettisoning valve must be designed to allow flight crew members to close the valve during any part of the jettisoning operation. Yeah, so if you certainly want somebody to be able to turn it off. It's out of control, we're losing all our fuel, or we've got another reason, or we're going to go on with our flight. The problem resolved itself, and we're going to go on, so we're going to stop the fuel jettisoning. Here's what a typical panel looks like. This one's what, a 767. It's basically the typical panels that you see. Looking at the portion of the panel one by one, seems like it's awful simple, but when you stick 60 of these, one on top of the other, it looks like quite an array of instruments. But this one here isn't, it's a fuel jettison panel. It is so identified. It will tell you that do not jettison with the flaps at 25 or 30. So it is possible. I would say that the prior illustration, because the flaps are up here, the ailerons are back there. So if the flaps are extended or lowered, it could interfere with the flow of fuel. So yes, you do not do that. Whoops, wrong direction. With your flaps lowered, in effect. What else does it say? There's a fault. I guess it's just a simple on and off if you want to jettison fuel. Or I guess you'd have to turn both. Turn it on and then press which valve you want so that you can lower the heavier tank if you needed to. Again, if you did exceed your landing weight, let's say in our prior example you wanted to land with the 30,000 pounds, you could structurally damage the aircraft. So they're not going to do that. They're going to dump. I know, what a waste, isn't it? But the waste of maintenance to repair an aircraft, let's just dump the fuel. Here's an example of that manifold, which would be in the black. Not much to say about this. They do point to this manifold isolation valve in the middle. All right, let's see what they have to say. This is probably a little more detail. One of the requirements was that you basically understand how the system works. So here's a Lockheed L1011 maybe, and only do it with the flaps up. Again, a different type of warning, so that's more for pilots. But there's a master, so you can jettison the whole system, or you can jettison the 4 different tanks. And that's the controls, and that basically goes to this fueling, defueling manifold. So in this case, they're using it for both. An isolation valve would probably make the difference from fueling or defueling. There's some dump valves here for defueling, and it looks like there's a dump valves. There's 4 of them, and then each wingtip does have a jettison valve, which is in effect the same thing. But you can see how the two left tank is pointing to that valve, and so basically each of the valves have their own individual control. No. All right, so what else does this say? Fuel from the tanks is pumped through the open tank dump valve into a fueling defueling manifold and is pumped overboard through the open left to right jettison valve and flame arrestor. If the left jettison valve fails to open, fuel could be jettisoned through the manifold isolation valve and the right jettison valve. So if the left, for some reason, is jammed, it's going to flow through the isolation valve and be jettisoned out this right jettison valve. You could always study this stuff a little closer, but just have a general idea. You don't have to memorize each item. You can see that the tank, that's enough with this illustration. There's a dump limit valve in each fuel tank that'll shut off the fuel if the pressure drops below what is needed to supply the engine with adequate fuel. It will also shut off the dump valve when the level of the tank gets down to a preset level. Let's say generally when you're jettisoning, you're just jettisoning off a percentage, maybe 20% of your fuel load. So it more than likely that calculation has been made. If you take off the fuel with the full fuel, what's that weight, and then what's the safe landing weight, and take the difference, calculate that into how much fuel you would have to dump in the most extreme situation, and then have a preset level, a shut off for that. And I'm sure that those levels, if you have to adjust them, are in the maintenance manuals. The primary get into a series of questions on fuel dump jettison. All right, first question. The primary purpose of an aircraft's fuel jettison system is to quickly achieve A, lower landing weight, B, balanced fuel load, or C, reduced fire hazard. It's clearly the lower landing weight. Jettisoning fuel is going to increase your fire hazard, and you're certainly not going to do that to balance your fuel load. You use a cross-feed valve, which is very similar to our fuel defueling manifold system. So quickly achieve a lower landing weight. Fuel jettison system is required under certain conditions if the maximum takeoff weight exceeds the maximum landing weight. What regulations cover the requirements of fuel jettisoning? Well, because I've been over it a few times. It was 23.1001, if I recall the exact regulation. And of course, that option is not available. There is only one that has part 23, so I'm going to pick that one, even though I'm not that sure. Well, 23 has to do with one category of aircraft, and 25 is the next category. It's odd numbers. I couldn't tell you exactly which one is which, but those two kind of go together. One of the next requirement might be a little less than the first requirement. And the cam is that Canadian CAM 4B, or is that civil aeronautical? One of the regulations before they codified it into the FARs. I'm presuming that's what it is. So B. Part 23 is the main item, and that's been throughout fuel has been our answer, is part 23. And then 25. But, if you have your FARs out, certainly leaf through it and you'll see there's also another category for 27, but it's probably for smaller aircraft that do not have a requirement of fuel jettisoning systems. However, it could. I mean, it's not based on size. It's based on maximum takeoff weight and maximum landing weight. So what is CAR is Civil Air Regulations? Yeah, that were certificated before the formation of the FAA. All right, these questions go back. They got some history, but technically, yeah, that's how they wrote up the legal citation back in the day. So as long as you know 23, you should be good. An oral question: why do some aircraft have fuel jettison systems? Well, there's only one answer, and it has to do with that takeoff weight and landing weight. That might be the easiest way to remember it. You can elaborate on those weights, but you throw in the word maximum. But I think if you get the difference, that's what the requirement of FAR 23 is. To allow the crew to reduce the weight of the aircraft down to or below the maximum allowable landing weight. You could actually say it better, but this does look like, no, that's that's a correct answer. So go with it. Is there any reason why a fuel jettison system might be required on a small aircraft? We were just talking about that. It's in the event that the takeoff weight exceeds the landing weight. A jettison system would then be required. Fuel jettisoning past the limits prescribed by the FARs is usually prevented by, what was that? Is it closely monitoring the fuel quantity and turning off the fuel dump switches visually and automatically by watching the fuel gauges, or a little more automatic? I would say a little more automatic. B, dump limit valves or a low-level circuit. Sounds like the right words to me. Or C, standpipes in the fuel tanks. Where do you study standpipes? How come? I thought it would be in this section. It's not the right answer. It is B, but it makes me, standpipes has thrown me off. It's fuel jettisoning is with dump limit valves, or certainly there could be a low fuel level circuit in the fuel tank itself, but we're pretty far into fuel systems, and so far I haven't seen the standpipe question. It may not actually be in this subject. No, well, that's certainly not what we're studying right now, so I just want to make sure I don't leave anything out. Normally, if there's going to be a question like this that you're going to face, I like to cover it and, um, you know, give a little explanation before we actually come to the answer of fuel of dump limit valves. But if there is not a question, or well, at least a question with the correct answer, I usually give that a little lower priority because if you're not going to be tested on it, uh, I mean, I'll encourage you to look into all aspects of the subject, but certainly the ones that you may be tested on should be uppermost in your mind. Fuel jettisoning is usually accomplished A, through a common manifold and outlet in each wing. So far, so good. Whoops, I got it on the answer, don't I? All right, well, I guess you already saw it. So, cat's out of the bag. It is through a common manifold and outlet in each wing. Um, we already kind of looked at the picture and determined that gravity flow was not going to take it into the outboard wing tanks, um, mostly because they're higher. So gravity is not going to flow up. Or C, individual outlets for each tank. Now, I mean, there may be individual valves for each tank, but the outlets are not individual for each tank. Yeah, sorry about that. But I know you know the answer. Maybe it's not quite worth going through and editing that. If I get a chance, I'll go through and edit that so I don't expose the answer before the question itself. So far, I've been doing pretty good without making that mouse roller mistake. All right, which of the following is employed to maintain lateral stability while jettisoning fuel? So the lateral stability, that's so that one side doesn't get heavier than the other. um, what can you do to make sure? Probably have the systems both empty at the same time, the left system and the right system at the same time, but each in effect with their own independent system. So I would think that the answer would be two separate independent systems. A. Crossfeed, I don't think you're going to go through a crossfeed procedure there. That is for maintaining lateral stability, but not when you're jettisoning fuel. C, two interconnected systems. Well, that really wouldn't work because they would have to. You would have to have in effect two different hose sources on each side of the aircraft, each operating independently. So you could actually control the flow on each one to maintain your stability. There is one system for each side of the aircraft. For what reason is a fuel jettison system usually divided into two separate independent systems, one for each wing? I guess it's the opposite of the last question. To maintain, you could just say stability, but if you want, it's fresh in our mind, lateral stability during fuel jettisoning. Probably a short enough answer. I don't think this is a long reason, but maintain. To help maintain lateral stability by jettisoning fuel from a heavy wing if necessary. That's a good way of saying it too. Fuel is moved overboard in most fuel jettisoning systems by. Now, here we go again. This time I'm not exposing it ahead of time, am I? How do you get that fuel overboard? Is it B? We know it's not going to be gravity because think of the wingtips as being higher at the tip than at the root of the wing. So gravity isn't going to work. So that eliminates B and C. So I know the answer is boost pumps. I'm just going, making double sure by, eliminating the wrong answers too. Even though immediately you know the right answer, make sure you eliminate the other ones. And don't let them confuse you too much because usually your first instinct is correct. Engine-driven fuel pumps, that's not, they're on the engine. So how are they going to get the fuel out of the fuel tank? So no, you need the boost pumps, which are installed right in the fuel cells or the fuel tanks that you're jettisoning out of. True or false? The fuel jettison valve must be designed to allow flight personnel to close the valve during any part of the jettisoning operation. Yeah, we talked about that a little bit. Let's say somebody's jettisoning the fuel and they forgot to close the valve again. So to prevent you from jettisoning all your fuel, it should be designed to allow somebody to be able to close the valve. So that is true. A safety consideration, and that was one of the things you wanted to know about. So avoiding the fumes inside the cockpit, jettisoning it away from the aircraft. We did see a little reference to flame suppressors in the tips. And here's another safety item. There must be a valve available to stop the jettisoning operation. And the final, true false. During the fuel jettisoning operation, the fuel must discharge clear of any part of the airplane. I'm sorry, I just said that, didn't I? But that is a true statement. I think that one we'd all agree on. No, you can splash some of the fuel on the hot engine. No, how about on the rudder? No, you don't want fuel on any part of your aircraft. So it's designed to do just that. All right, we got, that's a fair number of questions on jettisoning. So there's going to be a 3 or 4 minute summary in a review. I don't have much in the way of supplemental materials. All right, so I guess this one would apply more to this the L1011 or the 727, something with the 3 tanks, the right, the left, and probably the what we would say the number 2 tank, the one in the middle, in the fuselage tank. And there's either or both of the dump nozzles located in the wingtips. Got it. Fuel under boost pump pressure flows through the 4 electrically operated dump valves, through the automatic dump level control valves, into the fueling into the dump manifold. The fuel leaves this manifold through the electrically operated dump nozzle valves and exit the aircraft through the dump nozzles, or the dump chutes, I think have also been referred to. The normal dumping rate is approximately 2,300 pounds per minute. The mechanically operated dump level control valves will shut the fuel off automatically when the level reaches 3,500 pounds in each tank. If these valves should not operate, the dumping can be terminated by closing the electrically operated dump valves. Uh-huh. All right. I think I did find a few extra questions just in case. And they're probably similar to what we've already answered, but they're worded differently. And I know the FAA is in search of new questions, and that's why any of these published questions are fair game. Um, a fuel jettison system is required A, on all aircraft? No. B, if the aircraft's design landing weight is less than its maximum takeoff weight. Right there. C, on turbine engine aircraft only? No. Or if the aircraft's takeoff weight is less than its maximum payload, excluding fuel weight. The answer is clearly B because that's what we saw in the regulation. I would like to maybe give them credit for writing something that is close to it. It definitely would make you think. I'm not exactly sure. I like it. I give them credit for it. Next question. The pressure used to dump fuel overboard is provided by, we know that one, it's going to be the boost pumps. Excuse me. And finally, I think, if an aircraft is certificated with a higher takeoff weight than is allowed for landing, it must have and that's a fuel jettison system. I believe that's almost exactly what we've already saw. If not, I would have probably went back and looked and said, technically it doesn't read it that way. It probably read it the other way. A fuel jettison system is required when? If an aircraft is certificated with a higher takeoff. So I think they were flipped. But we know the right answer. All right. Appreciate that. Thanks for joining me, and it's a pleasure covering this with you. So I'll see you on the next one.